In a rational expression, remember that the variable or variables cannot take on values that make the denominator 0. These are values that we restrict from the domain of that expression. This is especially critical in solving rational equations that contain variable denominators. It is possible that in some situations we will solve rational equations and get solutions that make our denominators 0. If our solutions, when substituted back into the equation, create a 0 in a denominator of any rational expression, well, keep in mind that a fraction with a denominator of 0 is undefined. Thus, any number, any value of x that makes any denominator 0 in the equation, any denominator 0, must be restricted from the solution set. In other words, if and when we find the solution, our solution cannot be a number or a value that is restricted. Such solutions will be disregarded from our solution set. So we'll look at the equation here. It is a rational equation because it contains rational expressions. Solve the equation 7 over x minus 1 over 3x equals 8/3. Note that we have 3 fractions, thus 3 denominators, x, 3 times x, and 3. The first denominator of x is prime. The only factor in the denominator is x. Our second denominator, 3x, has factors 3 and x. Our third denominator, 3 is a prime number, thus 3 is the only factor in the denominator. Our LCD for these 3 denominators is the product of the factors 3 and x. Multiplying 3x on each side of the equation will get rid of our denominators. And let's see how this happens. 3x multiplied to the 7 over x, well, that's 21x over x. But what happens here? The 3x LCD and the x in the denominator, 3x divided by x is 3. The x is canceled, leaving us essentially with 3 times 7, which is 21. Distributing the 3x to the fraction 1 over 3x, well, the 3x LCD and our denominator of 3x will cancel outright, leaving us here simply with minus 1. On the right-hand side of our equation, the denominator of 3 and the factor of 3 in our LCD will cancel, leaving us with the product of x and 8, which we write as 8x. Now on the left-hand side of our equation, 21 minus 1 simplifies down to 20. So we have that 20 equals 8x. And now dividing off by the 8, what does x equal? X equals the fraction 20/8, which reduces down to the fraction 5/2. These are equivalent fractions, but 5/2 is the simplified version of 20/8. By dividing 20 by 4 to get 5, dividing 8 by 4 to get 2. 4 is the common factor of 20 and 8. So our solution x here is 5/2. Now, is 5/2 a number that we would restrict from our solutions? Right? What is the only number that would make our denominator 0 in our equation? We have 3 denominators. We have the denominator x, the denominator 3x, and the denominator 3. Can there be any value of x that would make any of those 3 denominators 0? Well, what about 0? If x equals 0, our first fraction is the fraction 7 over 0, and that's undefined. Likewise, for the second fraction, 1 over 3 times 0 is 1 over 0. That is undefined. X cannot equal 0. X can, in fact, and does equal 5/2. 5/2 is the one and only solution to our rational equation. How do we obtain this solution? We first determine the LCD for our 3 denominators using the factors of x, 3, x, and 3. To find our LCD must contain those factors of x and 3, thus 3x. Multiplying each side of our equation by 3x, getting rid of our denominators of x, 3x, and 3, we are left with a much easier equation to solve. And by solving this equation, isolating the variable x, we get a solution of 5/2. To solve the following rational equation, note that we have a rational expression equal to 7 plus a rational expression. For this rational equation, there are two denominators, and these denominators are exactly the same. They're x minus 2. Now, although they have the same denominator, of course, we know we can combine them using addition or subtraction, but here we're not worried about combining or simplifying expressions using addition or subtraction. We want to solve this equation, and this equation contains rational expressions. To make this equation a little bit easier to solve, we will consider getting rid of these denominators by first determining the LCD. And in this case here, because we have only one denominator of interest, x minus 2, that tells us that our LCD is going to be the one and only denominator of x minus 2. So we multiply both the left and right-hand side of our equation by x minus 2. On the left-hand side, 5x is being divided by x minus 2 and multiplied by x minus 2. So those x minus 2 factors cancel on the left-hand side, leaving us with 5x. However, on the right-hand side, the x minus 2 will multiply the 7. Thus, we have the product of 7 and x minus 2. Distributing the x minus 2 to the rational expression 10 over x minus 2, the x minus 2 factors cancel, leaving us with a plus 10. So our new equation here contains no denominators. And to solve this equation, we first get rid of our parentheses here by multiplying the 7 and x minus 2 to get 7x minus 14. On the right-hand side, we have three terms. Those last two terms, minus 14 plus 10, reduces down to minus 4. Now we have 5x equals 7x minus 4. Of these three terms in the equation, two of the three are variable terms, 5x and 7x. We need to be able to bring them together. By subtracting 7x on each side of the equation, 5x minus 7x is negative 2x. And on the right-hand side, we have negative 4. For our new equation, negative 2x equal to negative 4, dividing each side by negative 2, x is equal to negative 4 divided by negative 2, which is positive 2. We get a solution of positive 2. That is our solution to this rational equation. What is it you notice here immediately? You want to take this 2 and substitute it back into the equation so that you can confirm whether or not this is in fact a solution. What happens when you take 2 and plug it back into your equation? The fraction on the left-hand side becomes the fraction 10 over 0. We cannot have 0 in our denominator. Likewise, on the right-hand side, we get the fraction 10 over 0. The fraction 10 over 0, where 0 is in the denominator, we cannot have a 0 denominator. Thus, 2 cannot be a solution. Although we obtained that solution when solving this equation correctly, we note that this solution of 2 is restricted from this rational equation. It is the one and only one number that will make our denominator 0. We can't have that, so we restrict it. Therefore, the original equation has no solution. No solution will satisfy this mathematical statement. For exercise 25, solve the equation. We have a rational equation, 5 minus 12 over a equals 5/3. To solve a rational equation, first determine the LCD. Our denominators of a and 3, where a is prime and so is 3. The product of these two factors, 3a, is our LCD. Notice why we choose our LCD to be 3a, because 3a contains the factors 3 and a. Those are the two factors that are our denominators. So multiplying this 3a to this fraction will get rid of that a by canceling those out. Multiplying this 3a to this fraction will get rid of the 3 by canceling those out. That's why we're purposefully choosing to multiply by this value of 3a, because it's the LCD. It will be the one specifically chosen to get rid of our denominators. Distribute on the left side. 3 times a times 5 gives us 15a minus. Again, note that these a's will cancel, leaving us with 3 times 12. On the right-hand side, 5/3 times 3a, so the 5 is being divided by 3, but then we multiply by 3. Those 3's cancel, leaving us with the product of 5 and a. What do we have here? 5a equals 5a. Excuse me, I'm sorry, I got a line here on my screen. 5a equals 15a minus 36. So how do we want to go about solving for the variable a? Now, we have 3 terms. 2 of the 3 are variable terms. These are like terms, these 2 right here. The constant term is in the middle. We have this equal sign. To combine these like terms, to move it across the equal sign, subtract 15a. Or of course you can subtract 5a, but then you have to move the 36 over, that's fine as well. On the right hand side, how many a's do we have? 5 minus 15, we have negative 10 a's. A right now is currently being multiplied by negative 10, and this equals negative 36. Divide by negative 10. On the right hand side, we get a cancellation, and we're left with the variable a. Now on the left hand side, a negative divided by a negative is a positive fraction. So now we have this new ratio, this relationship of 36 divided by 10, or 36 over 10. Both of the numbers are even, so dividing a 2 at the top and bottom, 18 over 5. Our solution for a here is the fraction 18/5. And we want to look here and see, would that value for number 25, what is the one and only value a is not allowed to equal? A is in the denominator, a cannot equal 0. If a is 0, we get 12 over 0, and that can't occur. So that's the only value a is not allowed to equal. Well, it turns out, what does a equal? A equals the fraction 18/5, which of course can be written as a mixed number, 3 and 3 out of 5, also known as 3.6. So our solution here, 3.6, or the fraction 18/5. For exercise 32, solve the equation. Notice the special setup for number 32. This is a rational equation because it contains rational expressions. However, the setup here for 32 is a proportion. In other words, we have a fraction equal to a fraction. For number 32, when we have a fraction equal to a fraction, we can use cross multiplication to solve our equation. Go to the full view. Fraction equal to a fraction, thus instead of finding the LCD, which is just going to be the product of x plus 4, 4, and x plus 1, that's all that is, cross multiply. Multiply the 10 to the 4 to the x plus 1. Well, 10 times 4 is 40. And then 40 multiply x plus 1. This will equal the product of x plus 4 and 15. We will write it as 15 times x plus 4. Notice that we use parentheses there. I don't want to just multiply the 15 to the x. When we verbalize that 15 times x plus 4, we think it's 15x plus 4. But no, it's 15 multiply the entire number x plus 4. Thus, we will now use the distributive property. So we don't get 15x plus 4, we get 15x plus 60. This equals, when we distribute, 40x plus 40. So we have some x terms, some variable terms, and constant terms. Subtract 15x on each side. 40 minus 15 is 25x. Again, this is a result of balancing our equation by subtracting 15x on each side. Now moving over the constant by subtracting 40 on each side. So 25 is multiplying the x on the left side. We can balance this out by dividing 25 on each side. So what does x equal? X equals the fraction 20/25. but the numbers end in a 0 and 5, which means it's divisible by 5. We can factor out a 5. 20 is 4 times 5. 25 is 5 times 5. So our solution is 4/5. Is that a number of interest for us here other than being the solution? What does this denominator tell us? X cannot equal -4. What does this factor in the denominator tell us? X cannot equal -1. If X is -1, -1 plus 1 is 0 times 4 is 0. Can't have 0 in our denominator. If X is -4, -4 plus 4 is 0. Can't have that. However, a solution of 4/5 is okay. And it turns out it is the correct solution. It is the value that makes these two fractions equal to one another. For exercise 36, adding together the rational expressions equals the rational expression 20 over x. So the sum of two rational expressions equals the rational expression. To solve the equation, first determine the LCD for number 36. We will go to the full view. For a denominator of x plus 5, can we further factor? That answer is no. Denominator of x, the LCD is simply going to be the product of x and x plus 5. Why is this the case? LCD of x multiply x plus 5, well, this LCD here is going to eliminate this denominator of x plus 5. It's going to eliminate this denominator of x, and it's going to eliminate this denominator of x. Thus, the LCD. Distributing on the left-hand side, the x plus 5's cancel, leaving you with the product of x and 12, which we write as 12x. Plus, distribute, the x factors cancel, leaving you with x plus 5 multiply 5, which we will write as the product of 5 and x plus 5. On the right-hand side, this equals product of the LCD and 20 over x. The factors of x cancel, leaving you with 20 multiply x plus 5. Again, choosing specifically the LCD to multiply each side of the equation. Again, that's balancing our equation. We could have multiplied by a 5. We could have multiplied by x, y, z. It doesn't matter. We chose x times x plus 5 because this is the specific representation of a value of an expression that will get rid of our denominators, such as x and x plus 5. We have this new equation. To solve for the variable x, we first distribute the 5 and the 20 to the x plus 5 parentheses. So on the left-hand side, we have three terms that we can reduce down. 12x plus 5x. So think about it like this. ax plus b equals cx plus d. The variable terms we will want to combine together. The constant terms we will want to combine together. Let's start by subtracting 25 on each side. Where do I subtract 25? From the real number 100. If I'm going to move the constant over here, I need to move the variable over here. So I subtract 20x. On the left-hand side, 17 minus 20 gives us minus 3x. On the right-hand side, 100 minus 25 is 75. So what is x? What do you multiply to negative 3 in order to get positive 75? Well, it's negative 25. Negative 25 times negative 3, positive 75. We can see that because dividing each side by a negative 3, x equals 75 divided by negative 3, which is the integer negative 25. So what's our solution for x? X is negative 25. Now, for number 36, is that a problem? Can you plug negative 25 in such a way that it does not create a 0 in our denominator? Yes. And it turns out you can actually simplify that down. Negative 25 plus 5 is negative 20. So simplifying down that fraction, 12 over negative 20, which is negative 3/5, plus 5 over negative 20, we are adding negative 5/20, which is negative 1/4. Does this equal 20 over negative 25, which is negative 4/5? Check that, see if it confirms. Know that the solution is, in fact, negative 25. For exercise 50, notice the similarities between 50 and 32. Number 50, we have a fraction equal to a fraction. Thus, to solve this rational equation, we use cross multiplication. X minus 3 will multiply x plus 5. This will equal the product of x plus 1 and x minus 6. So we do have an equation. We got rid of those pesky denominators. So to solve for the variable x, we first distribute and distribute. So we FOIL here and FOIL there. We FOIL everywhere. Our FOIL terms combine on the left-hand side. Minus 3x plus 5x. On the right-hand side. So we have a trinomial equal to a trinomial. And now see here that the common terms, the like terms, are on each side of one another. So in order to bring them together, we have to do the properties of equality, adding the opposite. X squared is positive. So subtracting x squared eliminates it on the right-hand side. But notice what happens over here. Subtracting the x squared to balance actually gets rid of the x squared term altogether. So really what equation we have here is 2x minus 15 equals negative 5x plus 6. We've reduced down our equation from a quadratic to a linear because our quadratic terms cancel with one another. So 2x minus 15 equals negative 5x minus 6. This 5x over here is negative, so I'm going to move it over here by making it positive. By moving the variable term to the left side, I will move the constant term to the right side. The constant is negative, so we move it by making it positive. So what do we have? On the left side, 2x plus 5x. And what do we have on the right-hand side? A negative 6, a positive 15. Well, that's positive 9. So what number do we multiply to 7 to get 9? That is 9/7. How do we know that? Divide each side by 7. We can confirm that too, right? 7 multiply 9 over 7. 7 multiply 9 over 7. 7's cancel, leaving you with 9. So x is 9/7. The fraction 9/7 is the solution to our proportion for number 50. Remember that for any rational expression or any rational equation that is a proportion, in other words, a fraction equal to a fraction, then we can solve that proportion by cross multiplication. Using the FOIL method to simplify the left and right hand sides, we then combine like terms on each side of the equation by using our properties of equality. Solving for the variable x, we get one solution of 9/7. Number 51, 15 over x plus 9x minus 7 over x plus 2 equals 9. To solve the rational equation, find the LCD. The LCD will be the product of our denominators, x and x plus 2. Think about that. If we had some number that contained the factors that made up our denominators, then we would multiply by that number and get rid of our denominators. Luckily for us, that is defined to be the LCD. The LCD consists of all the factors that comprise our denominators. Here we have a factor of x and x plus 2. So our LCD is x times x plus 2. Now by multiplying each side of the equation by the LCD of x multiply x plus 2 on the left-hand side, this factor of x cancels with this factor of x, leaving us with x plus 2 multiply 15. We choose to write it as 15 multiply x plus 2. Normally when we distribute from the left side, but we can distribute from the right side as well. 15 multiply x plus 2, 15x, 30, same thing that we're going to get here. Distributing to the second expression, the x plus 2's cancel, leaving us with the product of x and 9x minus 7. This equals, on the right-hand side, 9 times x plus 2. So 9 times x is 9x. And now we multiply that to the x plus 2 by distributing. 9 times x is 9x squared. 9x times 2 gives us that 18x. So let's see what happens here, huh? On the left-hand side, we distribute as well. $15x plus 30. 9 times 9x, same thing up here. 9 times 9x, 9x times x. Going to give us a positive 9x squared. And now this positive x times negative 7 minus 7x. So on the left-hand side, we have a bunch of terms that we can simplify down. 15x minus 7x. Well, 15 minus 7 is 8. So that's 8x. On the left-hand side, none of these terms are alike. However, this 8x has a like term of 18x. This 9x squared has a like term of 9x squared. Like terms, same variable raised to the same exponent. Notice there's some x squareds in here, so it leads me to believe that there is a quadratic equation that lives in here. X squared implies some kind of quadratic equation. So in order to combine these two, I need to bring them together using the opposite of their signs. This 9x squared is positive, so I need to subtract. I subtract 9x squared here, do it over here as well. What happens when I subtract 9x squared? It cancels on each side. Leaving me with a linear equation, 8x plus 30 equals 18x. I have three terms. These two terms are the variable terms, so I need to bring them together. Subtracting 8x on each side. 18 minus 8 is 10, so we have 10x. What number do we multiply to 10 to get 30? 10 times 3 is 30. We know that x is 3 because a property of division on each side, divide by 10. We see that here our solution for x is in fact 3. Now go back to the original problem. Is that a problem for us for number 51? For number 51, what are the values that x is not allowed to equal? We'll consider what values of x make our denominators 0. For the first one, 15 over x, if x is 0, that's a problem. For our second fraction, denominator x plus 2, x cannot equal negative 2, that would also be a problem. For us here, fortunately, our solution is 3. X is allowed to equal 3, and see what happens if you plug in 3 there. For number 51, if x is 3, 15 over 3 is 5. For our second fraction, if x is 3, 9 times 3 is 27, minus 7 is 20 in the numerator. In the denominator, 3 plus 2 is 5. 20 divided by 5 is 4. So for that first fraction, 15 over 3 is 5. For the second fraction, we get 4. 5 plus 4 does in fact equal 9. So it confirms that 3 is in fact the solution to our equation. X equals 3 for number 51. For exercise 64, subtract the rational expressions. This equals the expression 4 over x squared plus 3x minus 10. Now to solve the rational equation, we first determine the LCD for our three denominators. To find the LCD involving variable denominators, we must first factor all three denominators to determine the factors that make up our denominators. Thus, we will determine the factors that make up the LCD. Give you a moment to pause the video to factor all three of the trinomials. All of these are factorable. There is no GCF. However, each of the three trinomials can factor into the product of two binomials. For number 64, two numbers that multiply to give us -8, that add to give us +2, is +4 and -2. Thus, the factored binomials, x plus 4 multiply x minus 2 for our first rational expression. X squared plus 9x plus 20, two numbers that multiply to give us 20, add to give us 9, that's 4 and 5. X plus 4 times x plus 5. For our third denominator, two numbers that multiply to give us -10, that will add to give us +3, that's +5 and -2, thus x plus 5 multiply x minus 2. Go to the full view. Our denominator, or our LCD, will consist of the factors of our denominators. So let's start from left to right. X plus 4 must be in the LCD. X minus 2 must be in the LCD. X plus 4 is already there, so we're good. X plus 5 must be in the LCD. X plus 5 already there, so we're good. X minus 2 already there, so we're good to go. The LCD is the product of these three prime numbers. If these represented real numbers, this could be the product of 2, 3, and 5, which is 30, right? This LCD could easily represent the number 30. However, in terms of the variable expressions, it's the product of binomial factors x plus 4, x minus 2, and x plus 5. How is this going to help us? If we take this LCD and multiply it to each of these three equations, what happens? Take this LCD and multiply it here. The x plus 4s will cancel. The x minus 2s will cancel, leaving you with the product of 2 and x plus 5. Minus this rational expression multiplied by the LCD. The x plus 4s cancel. X plus 5s cancel, leaving you with the product of 1 and x minus 2. Now on the right-hand side, this equals our rational expression multiplied by the LCD. When we multiply these two, the x plus 5s cancel, the x minus 2s cancel, leaving you with the product of 4 and x plus 4. We have rewritten our rational expression. How did we do so? We first factored each of our denominators, determined the LCD of our three denominators, multiply the LCD to each of the three terms in our equation. Right? This is the same as saying multiply on each side of the equation, thus multiply each term in the equation by LCD, giving us this new equivalent equation. This equation represents the same exact outcome as this rational equation up here, but what this allows us to do is solve it in a much easier manner, where we first start by distributing the whole numbers outside the parentheses into the parentheses. 2x plus 10. Distributing the -1, -1 times x, -1 times -2, And on the right-hand side, 4x plus 16. Over here we have 4 terms that we can simplify down. How many x's do we have? I have 2x, but I'm going to take away an x, leaving me with 1x. Plus 10 plus 2, 10 and 2 is 12. On the left-hand side, x plus 12 equals 4x plus 16. Need to somehow combine the x with the 4x, combine the 12 with the 16. Moving across the equation sign, I add the opposite. So combining the x's and the x and the 4x, I subtract x on each side. Right, this eliminates the x on the left-hand side. X minus x is 0. 0 plus 12, of course, is just 12. If I move the variable term to the right, I need to move the constant term to the left by subtracting the positive 16. On the right-hand side, the 16s cancel. What do we have here? On the left side, a positive 12 minus 16. We get a negative 4 on the left-hand side. 4x minus x, we get 3x. So x multiply 3 is negative 4. What is x? Negative 4/3. We see that by dividing 3. We get our one and only one solution to this rational equation, that x is the fraction negative 4/3. Now, can this value in any way make our denominators 0? Recall that our denominators were factorable. Our first denominator was the product of x plus 4 and x minus 2. Neither of those factors, when x is negative 4/3, will make our denominator 0. Our second denominator, product of x plus 4 and x plus 5, right, negative 4 and negative 5 will make that denominator 0, not negative 4/3. For our third denominator, that was factored into the product of x plus 5 and x minus 2, the values of negative 5 and positive 2 would make that denominator 0, not negative 4/3. Thus, for number 64, our solution for the variable x is the fraction negative 4/3.